Hi. Metals and nonmetals was one of the toughest subjects. We studied different aspects and different properties and different behaviors of metals and nonmetals. Now, let's look on to some questions. First, let's look on with 1 mark questions. Why does calcium float in water? When calcium is dipped in water, calcium hydroxide is formed and hydrogen gas is evolved. This hydrogen gas evolved sticks to the surface of the calcium and hence it floats on water. Arrange the following metals in the decreasing order of reactivity: sodium, potassium, copper, silver. The reactivity series is a series that is arranged the metals in the decreasing order of their reactivity. According to that, the answer is potassium is the reactivate, followed by sodium, followed by copper, followed by silver. Next question, why aluminum oxide is considered as an amphoteric oxide? Certain oxide behaves as acid, certain oxides behaves as base. But aluminum oxide is capable to act as acid as well as base. So such a kind of oxide which is capable of doing both characters are called amphoteric oxide. Aluminium is a less electropositive metal, so it forms amphoteric oxide which can react with acid as well as a base. Next, 2 marks questions. First one, give reason. School bells are made up of metals. Why? It's because metals are sonorous. They produce sound when hit with a hard substance. Second question, electric wires are made up of copper. Metals are very good conductors of electricity, especially copper, so it is especially used in electrical wiring. Next question, name the following: a metal which is preserved in kerosene, a lustrous colored non-metal, a metal which can melt with kept on palm, a metal which is poor conductor of heat. So a metal which is preserved in kerosene is the one which immediately catches fire when opened in the atmosphere. This is sodium. A non-metal which is lustrous is always iodine. That is an exceptional case. A metal that melts when kept on palm is gallium. It is also an exceptional case. A metal which is poor conductor of heat is lead. It is also an exceptional case. Next question, what is an alloy? State the constituents of solder. Which property of solder makes it suitable for welding electrical wires? As you all know, alloy is not a single substance. It is a homogeneous mixture of one or more metals. Solder is a particular metal of alloy. It is a kind of alloy. Solder's property is that it has very low melting point, which makes it available for welding wires. Next, 3 marks question. Suggest a method of reduction for the following metals during the metallurgical process. First one, metal A, which is one of the last, second or third position in the reactivity. Metal B, which gives vigorous reaction even with water and air. Metal C, which is kept in the middle of activity series. So as we all know, the reactivity series is divided into 3 different categories, and for 3 different categories, different approaches of methodologies are used in the extraction techniques. So, for the metal A, the best method is chemical reduction uses carbon or carbon monoxide as reducing agent. For metal B, the electrolytic reduction method is the best. And for metal C, it can be reduced by reducing agent like aluminium. It is the simplest extracting technique. Next, state 3 reasons for following facts. Sulfur is a non-metal, magnesium is a metal. One of the reasons must be supported with the chemical equation. Sulfur is a non-metal, magnesium is a metal. This is a basic idea that we know. Sulfur is a poor conductor of heat and electricity. Magnesium is a good conductor of heat and electricity. Sulfur is neither malleable nor ductile. Magnesium is malleable and ductile. A sulfur plus O2 gives SO2, sulfur dioxide. Magnesium plus O2 gives magnesium oxide. Sulfur dioxide is acidic oxide. Magnesium oxide is basic oxide. Next question, define the terms mineral, ore and can. As we have studied, mineral is a naturally occurring substance from which metal may or may not be extracted profitably or economically. It is one of the widest sources from which a metal can be extracted. Next, ore. It is a rocky material which contains sufficient quantity of mineral so that metal can be extracted profitably. Example, zinc blende is an ore of zinc from which zinc can be extracted profitably. Next, gangue. This is the impurity which is present along with the mineral in an ore. Ferrous oxide is gangue in the extraction of copper. So, this gangue removal is necessary in extraction. Next, long answer type questions, 5 marks questions. First one, write the chemical name of the coating that forms on silver and copper articles when these are exposed to moist air. Explain what is galvanization, what purpose is served by it. Define an alloy, how are alloys prepared, how do the properties of iron change when small quantity of carbon is added, nickel and chromium are mixed with it. So let's answer one by one. For the first one, when silver and copper articles are exposed to air, silver sulfide is formed on silver, copper carbonate is formed on copper. This means these metals have rust. Next question, what is galvanization? The process of coating zinc over iron is called galvanization. It is used to prevent rusting of iron. Next, alloy. An alloy is a homogeneous mixture of two or more metals. One of them can be a non-metal, one of them can be a metal, both can be metals. Alloys are prepared by melting two or more metals together. What happens when small quantity of carbon is added to iron? Iron does not rust on adding small quantity of carbon. Also, iron at the present time is soft. By adding carbon, iron gets harder. When we form alloy of iron with nickel and chromium, we get stainless steel, which is very well malleable, very well ductile, and does not get rusted. Next question, differentiate between roasting and calcination. Explain the two with the help of suitable chemical equation. How is zinc extracted from its ore? B part, name two metals that can be used to reduce metal oxides to metals. So first, let's go with roasting and calcination. Both are extraction procedures. Roasting is the process in which sulfide ore is heated in the presence of oxygen, in which the heating is done in excess air. Calcination is the process of heating carbonate ores in the presence of oxygen with limited access to air. As you can see, for roasting, zinc sulfide plus oxygen gives zinc oxide plus sulfur dioxide. For calcination, zinc carbonate plus oxygen giving zinc oxide plus CO2. How is zinc extracted from its ore? Zinc oxide, which is formed after calcination or roasting, is made to be reduced by copper. As you can see again, ZnO, zinc oxide plus carbon, giving zinc plus carbon monoxide. Two metals that can be used to reduce metal oxide to metals are aluminum and magnesium.